10,000 servers, same instance, and every single one needs a unique order number, and even right now. Hi everyone, my name is Raja Jamwal, and today we are talking about the Snowflake IDs, how systems mint unique IDs with zero coordination. The obvious answer is one shared counter in the database. Order 1, order 2, order 3, and each bigger than the last. Every server has to ask that same counter for the next number and one at a time. Add more servers to handle the flash sale, and they are all still queued up waiting on the one counter. That counter is now a bottleneck. And if it goes down, nobody can create an order. So split it up. Give every shard its own counter. No more waiting in the line. Shard A hands out order 47. At the same time and the same moment, Shard B also hands out order 47. The moment those orders meet in a dashboard or a search index or a support ticket, you have got two different things sharing one ID. Independent counters solve contention, but they do not solve the uniqueness. Fine, let every server generate its own random ID. A UUID, no counter, no coordination, virtually no collisions. Problem solved. Except now, look at where those IDs land in your database index. Random IDs insert in random places, splitting the page, fragmenting the index, everywhere at once instead of at the end. And you have lost something else. That is, just by looking at an ID, you can no longer tell which order came first. In 2010, Twitter needed a way out and stopped asking anyone for permission. Take a 64-bit number and split it. 41 bits became a millisecond timestamp. 10 bits identify exactly which machine generated it, data center and the worker. And 12 bits left over, a per millisecond counter for that one machine. Every piece is local information, no network call required. Worker 5 and worker 12 both mint an ID in the exact same millisecond, same timestamp bits on the both. But worker 5 stamps its own machine ID and worker 12 stamps its own. Two completely different 64 bits number generated in parallel with zero messages exchanged between the two machines. That is the whole trick. The coordination is replaced by identity. Now merge orders from 100 different servers into one feed. Because the timestamp sits in the high bits, sorting the raw numbers sorts them by creation time too. New IDs keep landing at the end of the index instead of scattering everywhere, the way random UUIDs did. One 64-bit integer, unique, roughly ordered, and built with information the machine already had. Twitter open sourced this as Snowflake, and it spread fast. Discord's message IDs, Instagram's sharded IDs, Metadon's local IDs, all Snowflake-style variants, tuned for their own systems. Different bits layout, same core idea. Timestamp plus identity plus a local counter. It is not magic, and it is not free. If a machine's clock ever jumps backward, it can mint an ID it already used. Most implementations just stall until the clock catches back up. And every machine still needs its own worker ID assigned somewhere. That coordination happens once at the startup, not on every request. Trade a little coordination upfront for none of it on the hot path itself. That's all for the today's video on Snowflake ID generation, and I'll see you in the next one. Thank you.